Alright, a box has 10 red, 20 pink, 25 black, and 30 orange jelly beans. You pick a jelly bean without looking. Find each probability. Alright, so P of red, that means the probability of getting red. Well, we have 10 that are red, and we've got to find out how many total jelly beans there are. So we've got 10 plus 20 plus 25 plus 30. When you add all that up, we get 85. So out of the 85 jelly beans, 10 of them are red. But that can be reduced. Both of these are divisible by 5, so this reduces to 2/17. Now the orange, there are 30 orange, and we already know that there are 85 total jelly beans. These are both divisible by 5 as well, so this can be reduced to 6/17. And the pink jelly beans, there's 20 of them, and we know there's 85, but that can be reduced. If we divide both of those by 5, we get 4/17. Alright, we have a stack of baseball cards that has 15 Cleveland Indians and 11 Cincinnati Reds players. There's a second stack of basketball cards that has 8 Cleveland Cavaliers and 5 Chicago Bulls players. You randomly choose a card from each stack, find the probabilities. Here, the first one is a probability of getting Indians and a Cavaliers player. Well, focusing on the Indians piece, we've got 15 out of a stack that has 15 and 11. The Cavaliers player there's 8 of them, and that comes out of a stack that has 8 Cavaliers and 5 Bulls players. Well, this is 8/13. So you have an 8 out of 13 chance of getting the Cavaliers player, and you have a 15 out of 26 chance of getting a Cleveland Indians players. You got to take this probability and multiply them together to see what the chances are of those two things happening one after the other. So we got 15/26 times 8/13. When you multiply that together, that gives you 120 over 338, but that can be reduced. So we're looking at 60 out of 169. Alright, what happens now if we look at getting a Reds player out of the one stack, and then out of the other stack we get a Cavs or Bulls player? Well, the Reds player, there are 11 of them in a stack that has 15 Indians and 11 Reds. And then this one, there are 8 Cavaliers and 5 Bulls players, and 8 Cavaliers and 5 Bulls players. Well, this gets you 13 out of 13. This gets you 11 out of 26. We need to take this and multiply them together. So, hold on, let me fix that. 11/26 times 13 over 13 is going to be 11/26 times 1, because 13 over 13 is 1, so it's just 11/26. You have a 6-sided number cube. What's the probability of these events occurring? Part A here, you roll an even number. Well, these are the possible outcomes: 1, 2, 3, 4, 5, or 6. The even, there's a 2, a 4, and a 6. So out of the 6 possible outcomes, 3 of them are an even number. So we have a 1 in 2 chance, or a 50% chance of getting an even number. Alright, let's say you roll a 4 and then you roll a 1. Well, your chances of getting the 4 are 1 out of 6. Your chances of getting the 1 are 1 out of 6. We multiply these together, and this gives you a 1 in 36 chance of getting a 4 and then a 1. If you roll 3 5s in a row, well, the chances of getting a 5 is 1 out of 6. Chances of getting that again, 1 out of 6. Chances of getting it again, 1 out of 6. So when you multiply this together, we get 1 out of 216. Alright, you have a bag of 30 marbles. 10 are blue, 8 are red, 5 are green, and 7 are orange. If you pick one marble from the bag, what's the probability that will be blue or orange? The key word here is the or. The blue, there are 10 out of 30. The orange, there are 7 out of 30. And when you're doing the or, that means we're going to add. So this gets you 17 out of 30 is your chances that you're going to have blue or orange. All right, you have a bowl of candy bars with 10 Snickers, 7 Kit Kats, 5 Hershey bars, and 12 Mr. Goodbars. Let's add these up and see how many we have total. We've got, I'm going to write it down here. There's 10, 7, 5, and 12. When you add all those together, we get 34. So in this first one here, what's the probability of getting a Snickers bar first and a Kit Kat second if we put the Snickers back in before we try to select the Kit Kat? So in other words, we get the Snickers, we put it back in, and then try to get the Kit Kat. Well, for Snickers, we've got 34 total candy bars, and there are 10 that are Snickers. For Kit Kats, we got 7. Okay, we're going to reduce the 10 34ths. That's 5 17ths. So we need to multiply those two together. So 5 17ths times 7 34ths is going to give us 35 out of 288, which is about a 6% chance of that occurring. All right, the next one here, what's the probability that we randomly get a Mr. Goodbar first and a Hershey bar second if we keep the Mr. Goodbar out? So we're going to pick the Mr. Goodbar, keep it out, and then try to get a Hershey bar next so we don't replace it. Well, if we look at the Mr. Goodbar, there are 12 of them. So we've got 12 out of the 34. And if we look at the Hershey bar, there are 5 of them. But now we have one less than before because we kept out the Mr. Goodbar, so there's only 33 candy bars. Well, 12 34s can be reduced. That gives us 6 17ths. So we need to multiply 6 17ths by 5 over 33, and that gives us 30 over 561, which is about a 5% chance of that occurring.